Okay, today's lesson is on parallelograms, special types of quadrilaterals. You remember what a quadrilateral was? It was a special kind of polygon. How many sides were on a quadrilateral? 4. Quadrilateral is a 4-sided polygon. Okay, so a parallelogram is a special kind of quadrilateral. It's going to have 4 sides, but there's something special about those sides. And that something special is that both pair of opposite sides are parallel. Notice our arrow markings here that indicate that these opposite sides are parallel to each other. Okay, so we had polygon is our big group of figures. A special type of polygon is a quadrilateral that has 4 sides, and now a special quadrilateral is a parallelogram where the opposite sides are parallel. Well, those parallel lines create all kinds of relationships that we learned back in chapter 3 when we had parallel lines cut by transversal. Well, when you have 2 sets of parallel lines where they are transversals to each other, you are creating that parallelogram. So let's think back to our parallel lines in chapter 3 where we created consecutive or same side interior angles. Okay, what was the relationship there between same side or consecutive interior angles? Who remembers? You should remember that they were supplementary. So in this figure, these 2 angles were going to add up to 180, as are these 2 angles because they are consecutive in this direction. That means that angle 3 and angle 6 would be congruent to each other. Okay, let's put some numbers in here that might help you see it a little bit better. If I say that angle 2 is 120 degrees, what is angle 3 going to be? Well, in order for them to be supplementary, it's got to be 60. Okay, well, if we go this way and we keep angle 2 at 120, then what does angle 6 have to be in order for these 2 to be supplementary? It also has to be 60 degrees. So notice that our opposite angles, when they're diagonal from each other, we call those opposite angles, are congruent. What is angle 7 going to be? Well, it is consecutive to angle 6 and to angle 3. So again, it has to be supplementary to angle 6 and to angle 3. The only option we have is 120, which we should have predicted because it is an opposite angle to number 2. So these opposite angles will be the same. And again, if we go back to what we learned in the last section, that a quadrilateral has an interior sum of 360 degrees, then we could have predicted this as well. So every time we learn a new relationship, it allows us to make predictions. And this prediction could have been made based on a couple of different rules that we have learned. So just go with the one that you remember. As long as it's true, you'll be good. So here are some relationships that you should know now for parallelograms. Okay, opposite sides of a parallelogram are congruent. Opposite angles of a parallelogram are congruent. Consecutive angles in a parallelogram are supplementary. And here's a fourth one that we didn't discuss. The diagonals bisect each other. There's that word again. It keeps creeping up. What does bisect mean again? It means that they cut each other in half. So the 2 parts are congruent. So here's what these relationships will look like when labeled in a parallelogram. Here we have our opposite angles being congruent. consecutive angles being supplementary, opposite sides are congruent, and here our diagonals are bisecting each other. So the two parts here are congruent. So if I told you that this one was 8, what is this one? 8. If I told you this whole thing was 10, what would the two parts be? If they're equal, then they have to be 5 and 5. Okay, so again, we're using our relationships to make predictions. So know those relationships. Another theorem says if a parallelogram has one right angle, then it has 4 right angles. Okay, well that makes sense. Again, this isn't a brand new idea. It's just building off the ideas that we just stated. If I know that this corner right here is 90 degrees, and it has to be supplementary to its consecutive angles, then the consecutive angles also have to be 90, because 90 plus 90 makes 180, right? 90 plus 90 makes 180. And if it is congruent to its opposite angle, then this one also has to be 90 degrees. So obviously, based on our past rules, if one corner is 90 degrees, all 4 corners has to be 90 degrees. Again, this is not a new idea. It's just taking the rule that we learned and putting it into a specific situation. If I draw a diagonal in a parallelogram, it cuts that parallelogram into 2 congruent triangles. So in this picture, triangle ABC here is congruent to triangle ADC. So I now know, let me erase that this part of this corner is going to be congruent to angle BCA. How else do I know that? What did I learn in chapter 3 that allows me to say that those two angles are congruent to each other? Remember, this is a parallelogram. So BC and AD are parallel to each other, and they are being cut now by this transversal AC. So I just created alternate interior angles, which are congruent to each other. Again, those past relationships that we learn are creeping up and helping us to learn and discover other relationships in different figures. So let's use what we know here. We know that ABCD is a parallelogram. Okay, so find X. All right, well, here's my X. What is that related to in this parallelogram? We just said that opposite sides are congruent. Okay, so its opposite side is 20. So if I set 4x equal to 20, then x is going to equal 5. Okay, again, this is a parallelogram. Find angle BCD. So I got to label that first. BCD. That's this whole angle right here. Well, how am I going to figure that out? Okay, I have these measures here, so I'm probably going to use those somehow. So I've got to ask myself, what's the relationship here? Well, if I look at the whole big angles, like whole big angle B and big angle C, these are consecutive, which we learned have to be supplementary. They got to add up to 180. Well, I've got part of it right here. What part do I have? I have 118. So what does this part have to be? It has to be 62, which is answer choice C. Okay, so you have to ask yourself, what is the relationship? Ask yourself, and then you should know the answer in order to solve these problems. Again, this is a parallelogram. Find BDC. So we just want this partial angle here. Okay, again, because it's an angle, I'm thinking it's going to be related to these angles somehow. Parallelogram is made of parallel sides. We've cut it by a transversal. These are alternate interior angles, so therefore they are congruent. So this has to be 54. So you can't forget your previous relationships that we've learned. Okay, so again, just think of your parallelogram as parallel lines cut by transversals, and that will help you remember all of these relationships.